Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson, for definite integration, we'll be continuing on with another example over here. So our example that we have for this part is double integration, whereas the area bounded is D. And then after that you have 65x squared y cubed minus 39 times dx dy. And D is the region bounded by x equals to negative 2y squared and x is equal to y cubed. So over here, before we even start to solve the question, we will have to draw the graph and also that later on we'll know the boundary and all those, right? So okay, so let's start off with our first function over here. So here we have x is equal to negative 2y squared. So y squared supposedly like this. So since the negative is going to be on the other side and the times 2 will make it a bit wider, which you're going to end up with over here it's not so smooth. Okay, so for this part, this will be x equals to negative 2y squared. Then what about for our x is equals to y cubed? So for x equals to y cubed, because that it's cubed, so for this part, even if there's a negative, this part is going to also be at the negative part. So what we're going to have here is something like this, okay, and over here we're going to get x is equals to y cubed, and this part is basically the area, this part is basically D, the region bounded, okay, so it's going to be something like this, so don't mind. Fine. Okay, so over here, now that we have gotten this part, what we're going to have here is, so now that we have gotten our area bounded, how are we supposed to find our boundaries? So apparently in this case, I am going to integrate with respect to x first. Sure, you can try to integrate with respect to y first and all. Well, it's your choice. So I'm going to integrate with respect to, well, for this example, we can. So for when we integrate with respect to x, we'll have to move like this. So it will go from this part to this part. Since we are only considering for this boundary the region bounded over here, so we're going to have from negative 2y squared to y cubed. On the other hand, for y, what we're going to have here is when is negative 2y squared equals to y cubed, because that there's going to be 2 points where they intersect with each other, and those 2 points are the points that we have to find for y. So apparently over here for this part, y cubed plus 2y squared is equal to 0, and thus y squared times y plus 2 will be equal to 0. So that would just show that y can be either equals to 0 or else y can be equals to, so y can be equals to 0, which will end up with a 0, or y can be equals to negative 2, so these two will will minus each other out and you will still get a 0. So you can choose either 0 or -2. So our boundary over here will be from -2 to 0. And now that we have gotten this part, what we're going to have over here will be, so for this part, as I told you, I'm going to integrate with respect to x first. So I'm going to straight away integrate it. And we will get 65 over 3 x cubed y cubed minus 39x from -2y squared to y cubed dy. Now we can substitute the boundaries inside and we are going to get, so when we substitute this inside, going to be y to the power of 3 to the power of 3 here. So while you see the 65 cannot be divided by 3, so you are going to leave it here. So y to the power of 3 to the power of 3, basically y to the power of 9, and when you times that to y to the power of 3, you're going to get a y to the power of 12. And now when you substitute this inside, because that this is a cube, so there's going to be a negative, and then there's another negative from the boundaries. So once you put them together, it's a positive, and we're going to have 65 over 3, and then this part had the 2, it will become 2 to the power of 3 times. So y squared to the power of 3 is basically y to the power of, so y squared to the power of 3 basically y to the power of 6, which will end up with, which you have this part 2, which you're going to end up with a y to the power of 9. And now you can substitute for this part, which you're going to minus 39 y cubed, and then this part minus, this part become positive, but because of this is a minus again, which you're going to end up with 39 times 2 times y squared, and then here you have dy. Now that you have gotten this part, what we're going to have here is, so what we have here is that we can, and so after this I'm just going to straight away integrate it. Whatever. Okay, so for this part, you can integrate, which you're going to get 65 over 3 times 13 from this 12 over here, and you're going to get y to the power of 13. Substitute from -2 to 0. Well, for this part, you're going to get over 10 from this 9, so you're going to have y to the power of 10 from -2 to 0 dy. Well, oops, there's not going to be a dy since you integrated it already. Then here you have a 39. Well, for this part you have a cube, so when you integrate it, it's going to be to the power of 4, so you're going to have a over 4 where y to the power of 4 dy. Then here you're going to have and then here you're going to have 78 over, so for this square it will become a cube, so over 3, and then y cubed from -2 to 0. Then for this part, what we can do is we can simplify it, whereas this will only be left with 5. So it becomes 5 over 3. Well, for this, if you sub in 0, it will still stay at 0, which you can ignore it. Then when you substitute this part inside, since you have a minus, so there's supposedly a negative, but since this is to the power of an odd, since this power is odd, so there's going to be another negative to cancel it out, and you're going to be left with this. And then for this part over here, you can simplify it, which you're going to end up with a 2, and then here you're going to have certain, well, I'm not going to simplify these two, and you will know why later. Well, over here, if you substitute this part inside, you supposedly have a negative. And since this power is even, so there is not going to be a negative coming out, so it's going to be a minus. That's 13 times 8 over 3 times 2, 2 to the power of 10. Then after that, you're going to add. So over here, so when you add over here, it's supposedly a negative from this part, but since it's a minus from the boundary, so it's positive. And since this is to the power of 4, so there isn't going to be another negative, so it is actually going to be a plus. 39 over 4, 2 to the power of 4. Then we also have this part, which we are going to have minus become positive, but since this power is odd, so negative, it's going to have another one, so it's going to be minus like this, okay? And now that you'll see for this part, if you didn't realize, what you can do here is well, you can just simplify this and get 13 then times 2 to the power of 4. Well, for this power, you're going to get over here, so when you over here, we can use a calculator for this part, and we will get so give me a sec. So for this part, you're going to have and if you calculate it, you're going to get negative 4148. Okay, so that is what you're going to get. So after you calculate this part, you're going to get a negative 4148, and that is our result for this example over here. So first of all, we had to draw the graph for both of these, and in order to find the boundary, we had to equate them to find the points, the 2 points where they intercept. Then after that, what we did over here, we integrated, then it will just be basic integration afterwards. So that is mainly all for this lesson. Take a quick look over here. Okay, last but not least, thank you for your watching.